know and love and experience, which is the three spatial dimensions and the one time dimension. But string theory is saying that on top of the three spatial dimensions that we experience, there might be some teeny weeny curled up, very small and cannot be probed type of tiny little dimensions, which when included by a requirement of string theory, as required by string theory, so you can't just include them optionally, they're required, will then become this theory that can be a theory of everything, is what string theory is saying, okay? But as you can see, those extra dimensions, because they cannot be probed nor experimentally tested, of course we won't know if this is really true or not, if this is really correct or not. We will see that if we will see that if string theory is correct, the fabric of our universe has properties that would have likely dazzled even Einstein. So it could be that the fabric of our universe, the fabric of space-time, is even more rich than what Einstein had imagined with his general theory of relativity, because he gave us gravitation as an explanation, which is the curvature, the bending of space-time, the fabric of space-time. So gravitation is not a force in general. It's not treated as a force in general relativity. You actually set the second derivative of position with respect to time. F equals ma, you actually set that to 0 in general relativity after you do the math with the four space-time, the geodesic and the metric and all that. So all of that is to say that gravitation is not treated mathematically like a force. It is the intrinsic bending or fabric of space-time. The more massive the object, the more it bends space-time around it, to the point where even light will be bent by gravitation. So this is sort of the big insight, right? This is really the big difference between Newtonian mechanics and general relativity way of understanding gravitation. Einstein was already giving us something deeply insightful about the fabric of the universe. The space-time business was not just, space and time were not just normal and ordinary in Einstein's math, right? String theory is taking that and adding even more dimensions, and in doing so explaining all this stuff in terms of its terms of its own way of treating these things with the extra dimensions. And so all of this is to say, if this is really true, if there really are these extra dimensions, then of course the fabric of space-time is even more interesting than we thought, right? So that's the state of string theory. So this is a little part from this book called The Elegant Universe by Brian Greene, with the E at the end of the name Greene. Hopefully you liked the state of string theory little blurb that I just read out of the book, and hopefully that kind of drives home the point of where string theory really is today. And it's not very conclusive, and it's still a work in progress, and that tends to be the case with a lot of research topics. So if you're able to kind of accept that it's a research in progress, then it's not too bad. Any questions, people? And we can do a little bit more reading too, but I wanted to pause a little bit and see how everyone is doing, and any more questions, any comments, any thoughts. I might keep the live a little bit short today, given that I'm a bit exhausted. Ooh, I'm actually going to rename this live. I'm going to rename it. I'm going to rename it State of String Theory. Wait, where do I go to do that? How is everybody doing? If you just joined, please do rewind the live to see the full thing. Ooh, and let me read your comments. It's gonna be like